believe we're live now. Hey, hi everyone. A very good evening to each one joined us today here. Thank you so much for joining us. Okay, great. Thank you so much for joining us on this training session two under Intel AI Hackathon, where we are here to make ideas to impact using OPEA. So, this hackathon is also powered by Hack to Skill. So, what are we here for, and what does this hackathon means to us? Is Intel's AI Hackathon is a national platform designed exclusively for AI developers like you. If you're a working professional and who's keen to solve real world enterprise challenges using cutting edge AI technologies, this is a great opportunity for you. At its core, the hackathon enables participants to build and deploy scalable, high impact AI solutions through the open platform for enterprise AI. And also, you will get a chance to explore Intel's Timber AI Cloud. So we are here for this training session two, building AI agents with OPEA. The session will explore building intelligent AI agents or using OPEA and demonstrate how to optimize strategies and workflows with Intel's powerful development tools. So without taking much of the time on this stage, because we've got a long session to go ahead. So I'd like to call today's key speaker and our mentor, Mr. Anish Kumar, AI software engineer manager, APAC Intel. Can we have Anish? Do we have Anish here? Hi, Anish.
Hey, hi,
Hey, hi. Hi.
hi
Now,
everyone. Good evening.
thank you for
I'll take
joining
over.
in. Yeah, you're
Yes,
audible. You can see you. Yeah, thanks.
great. Thanks everyone. Thanks everyone for joining. And hopefully my screen is visible. Can we have my screen displayed?
Yeah, it's there now.
Okay, sounds good. So welcome again. So today we'll have a brief working. We have a workshop on how to build and deploy AI agents with OPIA. And before I begin, there's some standard notices and disclaimer. I might show certain performance numbers or certain things. So there's a standard notice and disclaimer. So myself, as Shakti introduced, I'm the AI software engineering manager for the Asia Pacific region at Intel. As part of my role, I help enterprise customers to implement, optimize, and validate their AI solutions, specifically generative AI solutions from ideation to production or anywhere in between. So this is just the beginning of our journey. At any point in time, if you're developing any enterprise AI use cases and if you need any engineering help, feel free to talk to me. My LinkedIn address is there on the screen. We can get connected there. And if you are working on any of your enterprise use case, you need engineering help, my team can provide you with free engineering consultation on how to optimize your AI solutions to get a better performance out of your existing hardware and software stack. So with that, without much further ado, and we'll have three things to discuss. We'll be discussing three things today. We'll be briefly talking about AI agents, and then we will be talking about AI agents specifically with OPIA, and we'll conclude with a demo, Q&A, and some resources that probably might be helpful for you to work on your hackathon. So before I get started, I want to quickly talk about some evolution of generative AI and then AI agents, right? Then we'll get into AI agents. So that gives you the context and you'll be able to better appreciate why we have to use AI agents and things like that, right? So this graph that you see on the screen, it actually showing the evolution of generative AI, specifically the LLM models, right? At the very beginning and mid of 2017, Google introduced a model, transformer models, which was around 65 million parameters. I hope everybody is aware of generative AI specifically, like all the LLMs and what is the metrics used to calculate the complexity of those models, right? So one of the metrics that is generally used to measure the complexity of the model is called as parameters, right? And the parameters define how complex the model is. So mid of 2017, you see the graph. We had a transformer model, which is around 65 billion parameter model. And mid of 2020, we had GPT-3, which is around 175 billion parameter model, right? And this was the one that was publicly chat gpt when it was publicly available. This is the model that was used in chat gpt-3, which is around 175 billion parameter. Now we have GPT-4 and others which are more than a trillion parameter models, right? So one thing that comes quickly to everybody's mind when you are actually working with all these large language models is you might be easily be tempted to use a very large models like a 1 trillion parameter or a 500 billion parameter models. But if you actually go back, let's say if you ask ChatGPT what is the oldest data it has, I think it for me it returned the value as it has data from 3500 BC, 3500 BC all the way up to 2020. So if you're working specifically for an enterprise use case, let's say you're working for a banking customer and you're developing a banking KYC related application, right? Let's say you're developing a KYC related chatbot or an application that can process the KYC documents. You don't need data from 3500 BC all the way to 2020, right? All you need is you need the model to have a very basic general intelligence, and then it should have very specific intelligence about that particular bank's KYC processing systems, so maybe the local laws and regulations and rules and guidelines and all these things, right? So that's what is all required. Why do we need to be worried about that? One of the things is if you see the hardware requirement here, the screen actually shows you the amount of memory required to load a llama 7 billion parameter model. All right, this is how you calculate roughly how much amount of memory is required just to load that model, right? Just look at the numbers or the characters that are highlighted in yellow, right? So you are using a llama 7 billion parameter model, 16-bit representation, and it's almost takes the total amount of memory requires is almost 67 GB of RAM. This is the amount of memory required just to load that model. It's not, we are not even talking about right. We are not even talking about doing the inferencing, fine tuning, or anything. Just to load it, you need almost 67 GB, and this is just 7 billion parameter. In the previous slide, you saw the latest chat GPT and all is using 1 trillion parameters, right? 7 billion, 1 trillion. 1 trillion is more than 1,000 billion, right? So you can imagine the amount of memory that is required. So these are all a huge cost. There is a very huge cost involved in, and these are all very high-end hardware, right? It's not an hardware like the simple RAM that we consumer grade RAMs that most of our are used to. These are all like server grade RAMs. Those are very expensive, and also it's not only RAM that is required heavily. It's also the amount of compute power. It requires a huge amount of compute power to do all these calculations and things like that. Just to give you an idea, the amount of carbon footprint for different AI workloads, if you see the next slide, so in this slide, basically I'm showing you how much amount, what is the rough carbon emissions for different types of workloads. At the very left, you can see an air travel from New York City to San Francisco. If you're traveling from New York City to San Francisco, the one passenger almost contributes 2,000 pounds of carbon dioxide. And an average human life, it's around 11,000 pounds. And then US car manufacturing and fuel consumption, one US during its lifetime, it gives you around 126,000. But training an AI model down the extreme right, you can see that it contributes 626,000 pounds of carbon dioxide. That means it consumes so much of power that it needs so much of heavy compute power, and it's basically is contributing to a lot of carbon emission. It needs huge amount of compute power. It needs huge amount of skills, technically skilled people to do work on. So that actually poses a next question to everyone. So is Generative AI not the answer for all the enterprises. Only big enterprises, big kind of companies that has a huge amount of billions of dollars in their bank account, only they can use Generative AI? No. The solution or the recommendation is, what you can do is you can take up smaller models like a 7 billion parameter or 8 billion parameter model, and then, like I said, instead of having a model which has all the intelligence dating back to 3500 BC, you can take up a smaller model and then fine tune it or implement RAG, retrieval augmented generation, right, onto it. And then you can actually build models that are specific, that are very experts in specific domains, like the finance chatbot or the personalized marketing content or the code generator. I think is one of the pretty useful tools for you and me. It will help ease a lot of our workload. So if you would like to try, please try out some code generating models like Code Llama, uh, SQL Coder, or a lot of other different models are available for specifically for coding. Please use that, and it will help you that. So there are two ways to do fine tuning or RAG. Either you can use APIs like say the OpenAI's APIs or Azure or Amazon or any of these cloud providers APIs, and then implement your own fine tuning or RAG on that. Or you can also take up, let's say you have your own lab machine or your own on-premise machine. What you do is you can take open source models like Llama, Falcon, Bloom, Mistral, or tons of other different types of open source models that are available. Take that and you can implement the fine tuning or RAG on that. So the one question that might arise is, when do I use fine tuning and when do I use RAG? The answer is probably might end up using both. So whenever you have a huge amounts of historical data, take all those historical data. Let's say you have the KYC guidelines, the local rules and regulations, uh, the government of India's laws, like all the IPC section laws and all the different laws and all those things. Take all those things, and probably for that KYC example that I was talking about, you can do a one-time fine tuning of that model. And as part of the real-time inferencing, you can, if you have any real-time information that keeps changing, that keeps changing on a day-to-day or a hourly basis, or things like, let's say for a stock trading application, you cannot have only fine-tuned model, right? Because fine-tuned model only knows historical data, it doesn't know the real-time data. So whenever you have a use case like a stock trading application that needs access to real-time data, right? For example, what's the political scenario or what's the economic conditions, and things like that, then probably can implement RAG. So the best case scenario is fine tune a model with all the large amounts of historical data and feed it with the real-time data that you might have, and then in that case your model will behave more accurately. It will give you more accurate answers to your questions. So remember two things: when you have large amounts of historical data, do fine tuning. When you have smaller amounts of real-time data, use RAG. In best case scenario, use a mixture of both, so that you have the best of both the worlds. Coming to the hardwares that can be recommended. Now this is what you see on the screen is just a recommendation. Let's say if you have a 1 billion parameter or less, you can use AI PC or the Intel Core Ultra processors for doing the endpoint inference. The Core Ultra series of processor that has the traditional CPU cores, it also has GPU, as well as the new type of compute element called the neural processing unit. All three type of computing element in one silicon die. So that is called as AI PC or Intel Core Ultra. I think most of you are aware of the Core i7, i3, and other processors. But the Core Ultra is a new generation of processors that has specifically designed for AI workloads, that has all these three compute elements in one silicon. You can use even a 7 billion or a 13 billion parameter easily. Recommendation is generally 1 billion parameter. And if you have up to 20 billion parameter, you can use a single socket Xeon server grade CPUs. If you have 100 billion, you can use multi-socket Xeons or the Gaudi accelerators. And for more than 100 billion, definitely you need multi-node deployment of racks, like multiple machines. And definitely, if you're using a huge machines, huge, if you're developing your own state of the art models, probably might want to use cluster of data centers, clusters and data center scale computer power, right? There are certain requirements also, right? Say in India specifically, most of these large language models are all English-based languages, and there's always a need to develop custom localized language-based models, like models, LLM models that can understand Kannada, Tamil, Malayalam, Hindi, all the other different Indian languages that we have. So definitely there is a huge demand for those localized language-based models, and people are starting up to develop their own models in those local languages. And definitely you might need a data center scale compute power to train those different models. So hopefully we got a very brief idea about what are the different challenges that are there in specifically when you're implementing generative AI solutions in an enterprise scenario, and how to address those solutions, right? So don't go with the hype that you always need to use a very large model like a 500 billion or a 1 trillion parameter model. Go with a 7 billion in most majority of the use cases. A 7 billion parameter or less than 10 billion parameter model is more than enough for enterprise use case, as long as you are doing a fine tuning or rag on that. As long as you are implementing this strategy, a 7 billion parameter model should be more than enough. So that way you're overall reducing your compute power and also ensuring the accuracy of your models are increased, right? It gives you better accuracy than an untrained, unfine-tuned larger models. So with that, now we can switch over to what's the difference between generative AI and agentic AI, right? If I had to say what are the key differences between a generative AI and an agentic AI, generative AI are reactive, right? That means you need to prompt for it, and then only it will react to that prompt. But agentic AI are proactive, right? They don't wait for prompts for you, right? They basically the prompt gets triggered from some kind of an action, something happens in the environment, and basically from that the triggers. Yeah. So the generative AI waits for the user to enter the prompt. Like it might ask, wait for you to enter something so that it can give an inference for that. But the agentic AI, its prompt is triggered. Prompt is triggered due to some kind of a situation, some kind of an environment condition, or something happens, and then the prompt is triggered in an agentic AI. And generative AI generally generates text, image, code, audio, video, all these types of data types. Agentic AI generally executes action, right? Like you give the prompt is triggered, and based on the prompt, it will actually executes an action. And both uh, generative AI as well as agentic AI use a lot of LLMs to get their uh, get their things done. So with this idea, we'll try to get in depth of AI agents. What are AI agents, and how what are the key things that an AI agent does? So there are four steps in an AI agent, right? One of the very first step is it actually collects data. Like I said, an AI agent is a proactive one where an prompt is triggered. For the prompt to trigger, it actually collects data from its environment, or it understands the context of its current system settings, right? Or the current processes. Tries to understand the context or collects data from its environment, and then the second step, it will try to determine what is the best action to take for this given context or for this given data set that the environment is in. And based on that action, it determines, it executes that action. That's the third step in this overall thing. Once it executes the action, the outcome might be positive or it might be unfavorable outcome, and it learns from its feedback. It learns from its actions results and loops that learning back into the system, so that the very next time if it encounters a similar situation, it can learn from that and it can perform better instead of doing the wrong things again, right? So four steps: understand or collect information from the environment, determine what is the best action to take, execute the action, and learn from the action. These are the four things that a typical AI agent does. Now, if I have to briefly differentiate between an LLM workflow and AI agents again, right? As we discussed earlier, LLM, you give an prompt input, you'll get an output. Like it can, the output can be text, image, code, audio, video. In an LLM workflow kind of a system, you have an input that goes to different LLM systems, and those LLM systems are interconnected to different tools via hard-coded codes, right? These are codes that are based on certain logic. That, and this logic, business logic, is all hard-coded with your code, and it's predetermined. For one particular condition, it always goes to this particular tool. So it's all predetermined. So you know what is the scenario that might you might encounter, and based on that, you are hardwiring it to use particular tools. And from the tools, you are getting the output. That's the workflow. But in an AI agent's perspective, you have an input, it goes to an LLM system. The LLM system routes that to an AI agent that actually dynamically determines, based on the environment it is, or the based on the context it is, it will try to determine what is the correct tool to use. Dynamic decision happens. So very brief differences between an LLM system and a workflow and an AI agent. So what are the key benefits of using AI agent? One of the key benefit is efficiency, right? AI agents handles interactions simultaneously and reduces the response time and cost. I mean, it can handle multiple requests at a time, and can definitely reduce the overall response time, and it will be more close to how an human interaction happens. And it also gives you better personalized customer experience. And the other thing is, it's a very consistent and accuracy, right? The accuracy, since it keeps learning from its past mistakes, the accuracy keeps improving over time, and there's always a consistency in how the way it behaves, and this reduces the overall risk of errors with reliable information. And next is availability, right? Since it's all AI agents, and definitely it's all running on machines with or without a human in the loop. Most of the systems can be developed without human in the loop. Certain critical systems might have human in the loop. Um, so in majority of the use cases, it can be availability can be 24 bar 7. And it's also data driven insight. It's not based on somebody's domain expertise or things like that. Definitely, domain expertise is required, but additionally, it also is heavily driven by the data that comes in, right? As and when the data keeps changing or the environment context changes, AI agents do do improve themselves. And last one is scalability. AI agents can scale to handle large volumes of interactions without compromising on the service quality. Now we'll talk about OPEA AI agents. So OPEA, all the AI agents are mostly composed of a lot of microservices, and most of the microservices related to planning, action, observation, and reflection. All this runs on a CPU, and agents, microservices related to LLM inferencing can run on a Gaudi accelerator or on a CPU or a GPU that you might have. So what you can do is, all the non-traditional, non-generative AI, non-LLM based workloads or a microservices can use the CPU. And if you are using a smaller LLM models, probably you can run it on the CPU itself, or you can use if it's a bigger one, you can use a Gaudi accelerator, or if you have a GPUs, you can definitely use the GPUs. And the agents are equipped with multiple tools. Each agent microservices are equipped with multiple tools. Like you can see on the screen, there's a web search tool, there's a private file retrieval tool, there's a SQL database query tool, or maybe other kinds of tools, maybe like it was something that connects to your Jira or maybe GitHub or maybe some of your SharePoints or something like that. So there are different types of customized tools that you can build that can interact with the CI agents. So remember, one key thing in OPEA is OPEA's all the architecture is based on microservices. Each of those things, each of these modules are a separate microservice that is like a separate Docker container. So it can individually isolate particular containers and do a lot of things. And if you have to understand why do we want to use a RAG, right? Like if you have to use a RAG agent versus a conventional RAG application, what are the advantages, right? So in this table, we are showing a benchmark. There's a open benchmark called comprehensive RAG benchmark. The URL for that is flashed on the screen. It's an industry standard benchmarking exercise that was introduced by Meta or the founders of Facebook. It contains a simple fact-based questions as 7 types of complex questions such as comparison, aggregation, and set of questions to test the reasoning and synthesis capabilities of the RAG solutions. Right? These are a very standardized way of testing a RAG application. And score of 1 means it's like absolutely very good. That's the absolute very good score that you can get. And you can see on the from the table, the very first row has conventional RAG. It gives you an accuracy of 0.37, while as a single RAG agent you have only one RAG agent. If you are using only one RAG agent, then it slightly improves better than a conventional RAG, but it's still around 0.43. But if you are using in hierarchy of multiple agents, right, then definitely there's almost like 15 to 30% or 40% improvement in accuracy that you can see. So I'll recommend whenever you're developing an AI agents and things like, probably you can use this kind of benchmarking for your hackathon and see how your AI agents benchmark, excuse me, how your AI agents bench accuracy is improved, and this learning you can apply it in your professional work as well. So the value of OPR CI agents versus any other OpenAI's agents are OPR CI agents are fully open source and free to use. There's no cost involved for you, and it's all the source code, all the Docker containers, all the documentation, all the examples are all freely available for you on the GitHub. We'll share the link to you shortly. And it also gives you more privacy with models and data, right? That is also one of the concerns when you're dealing with sensitive enterprise data. Probably you might want to hold the data within your ecosystem, so it gives you that option. Also, it's compatible with OpenAI Assistance API with drop-in replacement. What do you mean by that? All the OPI agents exposes APIs that are OpenAI compatible. That means OpenAI, if you are aware, OpenAI has an REST-based API to access their services, right? It's an industry, and that has kind of become an industry standard for how to interact with OpenAI. So we are using the same industry standard. So OPS will give the same industry standard APIs. So all it takes is just change the base URL, and if you change the base URL, you can unplug OpenAI and then plug in your own systems. Also, it's a low code and no code platform. It gives you with a small modification to Docker Compose YAML files or other configurations. You can add and grow your tools. You can configure things as per your needs. So this gives you the overall picture of the different value addition that an OPI AI agent gives you. So I would recommend, if you're developing any applications for your hackathon, please try to use all these different OPR tools that are available and try to benchmark it and show those results and see. Don't only work for the final price. Price is definitely a motivation, but also use it as a learning experience and learn. Try to implement certain real world use cases, probably certain things that your own organization might be facing, some challenges your organization might be facing. Probably you can use this opportunity to develop solutions for that and add real value for the users. Here is an example. There are, if you go to the OPS GitHub repository, there are almost some 20 different, 20 more than 20 different examples that are available. Various kinds of examples. One of the key things with OPEA is OPEA's all the examples that are available on OPEA are all enterprise grade. That means it has been designed, architected, integrated, integrated, optimized, and validated for enterprise use, right? So if you are worried about optimizations, like you might be using, let's say, Intel's CPUs, if you don't have to specifically do any additional optimizations. All the optimizations that Intel has is already upstream, and definitely a lot of other companies like AMD or SAP Labs or a lot of other companies. There are more than some 50 different companies are part of this OPEA platform. I think we might be already be aware of it. So I'll not get into the details of that. They are all actively contributing to this OPEA platform, and they all include their own optimizations and their own knowledge into that. So OPEA, using OPEA as a starting point for any of the enterprise use case, gives you this advantage that it is integrated, optimized, and validated for enterprise use case. That means all your security guardrails, scaling options, and things like that are already monitoring, and all these things are already taken care of, so that you can focus on your core problem, building your core solutions rather than on the basic nitty-gritties of the building up an AI agent. So in this, one of the examples is agent Q&A. If you go to the GitHub repository, that the link is there on the screen, you can get all the complete source code, including all the Docker containers, everything for that. This is how the overall simplified architecture looks like. You have at the very top, you have a supervisor agent. The supervisor agent can talk to multiple worker agents, or it can also talk to different tools. One of the agents is a RAG agent. There is also an SQL agent. An SQL agent talks to an SQL database. A RAG agent, as the name implies, it will talk to an RAG retrieval tool that eventually talks to a vector database, right? Or it can also be interconnected to other tools. Maybe you might be developing an application that can talk to, say, GitHub, or it may be some other proprietary tools you might be using it. So you can actually interconnect your own different tools like Jira or any other tools, maybe a finance related some kind of an analysis tool you might have, like a Bloomberg. Let's say you would have signed up for Bloomberg's API. You might have Bloomberg API access. You can connect to Bloomberg's API or other different data sources. So the supervisor agent can be connected to all these different types of agents very easily with just simple configuration in the Docker Compose files, and that will enable you to connect, make your agent more powerful, and it's pretty easy to do that. It's and if you need always any help, like I am always there. We can get connected on LinkedIn and ensure that we'll give you all the different support that you need. Uh, if I have to break down that architecture here, these are the various types of microservice agents that are available. There's a microservice React agent, there's a microservice SQL agent, there's a RAG microservice agent, there's a data preparation microservice, there's an embedding microservice, retrieval microservice, re-rank. So I'll not get into the details of these different types of microservice. This is all standard different types of services you might encounter in a Generative AI RAG applications. So these are different types of services that are there. If you need any additional information on any of these things, like say what is a retrieval microservice or what is a re-rank microservice, please ping us after this call, or maybe you can also Google about. These are all standard things. It's not like something new that OPI has invented or Intel has invented. These are all the industry standard things that probably you have to know, right? So this is how this in different agents, like there's a on the extreme left you have the user input query that goes to an React interface. That's again a microservice. That React interface will determine if that data has to go to an SQL data agent or should it go to an RAG agent, and from there it goes to an LLM service, and finally from LLM service the output can go back to the user or things like that. So it's a pretty self-explanatory. It's not a very complex architecture, but definitely it as we have ensured that all these microservices are extremely tested for all the different enterprise use cases, like ensuring all the security related things are taken care of. It's scalable and it's optimized for the different hardware dynamically. They are based on, if let's say if you're today you're running it on Intel hardware, and tomorrow let's say you're running it on Intel Xeon today, maybe development happens with Intel Xeon, and finally when you're deploying it, it might be with the Intel Gaudi. So you can actually move it. When you're actually moving your code, you don't have to rewrite any of your code. It will automatically determine what is the kind of hardware, underlying hardware. Based on that hardware, it will basically change the optimizations that are there. So with this, now we'll have a very short demo of one of the AI agents. So the next AI agent demo that I'll show is an SQL agent. What I have is I've built a simple interface and I have connected an SQL agent, and let's do some simple query on that SQL agent. The SQL agent is basically contains a lot of information about music albums, and we'll query a music album and see what's the output it spits out. So I'll just try to play this video. Hopefully, I think the screen, some of the letters might not be clearly be visible, but I'll try to explain to you what exactly it's happening. So here, what I'm trying to do is I have this SQL agent which is filled up. The SQL database is filled up with a lot of database related to and music albums, and I ask the question, which artist has the most albums in the database? It actually trying to find what is the appropriate. Now it's trying to search for which is the appropriate tool to use. It comes to a conclusion that for this the appropriate tool is search artist database is the appropriate tool. There's a tool called search artist database, and it's actually trying to query which artist has the most albums, and it has come up with the answer saying that, if you see the answer says that the artist with the most albums is Iron Maiden with 21 albums. So basically, what it did was it had only one agent, one tool that was connected to that agent. That was the SQL tool, SQL agent tool that was connected to it, and it queried the SQL database for which artist has the most albums, and it spits out the answer saying that Iron Maiden is the album which has most albums. Now, if you have a scenario, let's say you have a scenario where the agent doesn't know the answer. Let's say I want an same database. The database was populated with a certain information on a certain time period of time. Let's say I had loaded it with data before 2023, all the albums before 2023, music albums before 2023 was loaded into. Just give me a moment. Sorry about that. So let's assume that the agent was SQL agent, SQL database was loaded with data from prior to 2023, right? Now, if you have that, and if I am querying something related to 2024, it might want some real-time information, right? In that case, I'm asking here a question: which female artist has the most albums on Spotify in 2024, right? So probably this might not be available in the SQL database. So let's see what the AI agent does. So queried which female artist has the most albums on Spotify in 2024. It's actually trying to figure out the best tool to use, right? It's trying to see if I have to use a SQL agent, a SQL search tool, or that's to. I think it's coming to a conclusion that it has to use a web-based search tool. So let's see what the tool comes up with the answer. So it's I think it is determined that it has to use search web-based tool, right? It wants to use the web-based tool to search the internet. So it use the tool and it actually search the internet for the answer, which female artist to use, which female artist has the most albums in Spotify in 2024. So the answer it came up with is, I think it is Taylor Swift. Yeah. If you see the answer, the tool calls have mentioned Taylor Swift as the top global artist of 2024 with her album, The Tortured Poets Department, the anthology, right? So determine that for this particular answer, I cannot get the answer from an SQL agent. Instead, I need to get the answer from a web-based tool so that it goes to the web, maybe to Spotify, and then search there and try to get the answer. And it comes out with the answer saying that Taylor Swift's album, The Tortured Poets Department, the anthology, is the album with the female artist has the most albums on Spotify, right? So with this demo, these are the different types of. This is a very simple AI agent that we have built. I'm definitely sure you can use this inspiration to build your own AI agents for your hackathon specifically and for your enterprise use cases. So please use that, and I think we are open for Q&A, and definitely we can get connected on LinkedIn, and that's my LinkedIn address. We can get connected there, and our hackathon is just the beginning of our journey. Like I said earlier, if you have any enterprise AI use cases, feel free to talk to me. I'll get my engineering team to help your engineering team to help them to implement and optimize and validate your AI solutions right from ideation to production or anywhere in between. So with that, we are open for Q&A, question and answers. And if you don't have any questions now, you can always come back to us. We have our support channels there. Probably we can always use that support channels to get your questions answered. Meanwhile, I have some key takeaways. These are some of the key takeaways. Remember, OPEA provides you with a suite of microservices and examples of generative AI applications, fully open source and customizable. And OPEA also follows OpenAI API standards. Like I said earlier, that's easy to integrate into your existing GenAI applications. We have also optimized agent strategies for open source LLMs, and you can start to build your agentic application by just configuring the Docker YAML files. And you can use OPEA to build single agent or multi agent applications. I am definitely eager to see all the different types of applications, AI agents that you are going to build and solve some of the real world challenges using this hackathon as the opportunity. Some resources that you might want to use, intel.com/AI gives you a lot of information on the AI. There's Intel CI software tools, VLLM. OPEA definitely is available at opea.dev, and definitely a lot of OPEA projects are there on the GitHub. OPEA documentation as well. And for call of action, check out our agent microservices in GenComp's repo under GitHub. If you go to the GitHub, there's a GenComp's repo. You could use that GenComp's repo to build your own application. If you don't want to use any existing GenAI applications that are provided in OPEA, if you want to build your own things, use those components repository and stitch up the components together and build your brand new application. Or you can also use the GenAI examples repository to take that as the starting point to build your own applications. I think with that, we can conclude unless anybody has any questions.
Great. Thank you so much, Anish. I believe you can hear me.
Yes, yes, we can hear you, Shakti.
Okay, great. Thank you so much, Anish, for all the insights for today's session. I believe everybody watching us have learned a lot during this session. You can always refer back to this link in order to catch hold of everything that Anish just spoke about. But we are truly excited and about So I learned a lot. Like I got a lot of insights about OPA as a platform. I believe so do everybody watching us has got an insight on, and had a learning about OPA's platform. But in order to get that through, thank you so much, Anish, for the walkthrough. I believe there are not much questions here, but you can always reach out to us on our
Yeah.
support emails. It's Intel AI Hack Support at the rate hacktoskill.com. You can reach out to us there. There's a Discord separate channel that has been created for you guys. In case you're facing any difficulties during the hackathon or any phase of the hackathon for the platform or maybe the tools, maybe it can be as small as finding a team member, right? You can always reach out to us. We'd be more than happy to help you sort your issues. But for the people who are watching us for the first time here or new, you've not registered, please do check out the website, register yourself. It's a great opportunity. It's something that has come, it's only for working professionals. In our previous session, we mentioned that we'll get back soon with something for the students as well. But this one is only exclusively for only working professionals. Hence, make sure if you're a working professional, do check out the website. You can simply go to hacktoskill.com and you can find that, or you can also go to the link. We can share that on the chat. Just go through the website. You'll learn more about the hackathon. You get more insights. Once you register, you can find the links to the recording session of this one and the previous one as well. We also did an introductory session wherein we have included everything. We have talked about the themes, we've talked about the prize pool, we've talked about the overall journey of the hackathon as well, right? If you want to refer back to that, please do register yourself. Check out the participation dashboard. You should form teams of minimum 2 members to max of 3. So make sure you do that. And if you're somebody who already registered, you're part of it, make sure you make a brilliant submission, think it through, you know, the, take consideration of everything that has been taught, right? For OPEA. So using OPEA is one of the mandates of the hackathon. So make sure you have that with you. So with that, thank you so much everyone for watching us. Anish, if you want to add something to this.
Yeah, I wish all the participants all the best, and eager to see all the great applications that they're going to bring up.
Wonderful. Looking forward to it. But thank you so much, Anish, again for joining us today, sparing the time. And we look forward to engage with you very soon.
Sure. Thank you. All the best, everyone.
Thank you. And thanks a lot for all the participants joining us here today. We will soon be sharing another email to capture your inputs there. Make sure you keep an eye on your inbox. But thank you so much. Have a nice evening. Thanks, Anish.
Thank you. Bye.